Alrighty, let's see if we can close out the month quickly. Find the closest node to given two nodes. You're given directed graph of n nodes numbered 0 to n minus 1, where each node has at most one outgoing edge. Okay. Graph is represented with a given zero index array of edges of size n, indicating that there's a directed edge from node I to node edges at I. If there's no outgoing edge from I, then edges of I equals -1. So the number of nodes is the length of edges. Okay. And edges is just an array of integers where the ith node is connected to edges at I. Okay, I think I understand that. Or -1 if there is none. And then you are also given two integers, node 1 and node 2. Return the index of the node that can be reached both sides from both node 1 and node 2 such that the maximum between the distance from node 1 to that of node to that node and from node 2 to that node is minimized, such that the maximum between is minimized. If there are multiple answers, return the node with the smallest index. And if no possible answer exists, return -1. So the edges make insane cycles. Excellent. So here, node 0 goes to node 2, so that means the first element in the edges array is 2. 1 goes to 2, so the second element is 2. 2 goes to 3, so the third element is 3, and then 3 goes to nothing, so there's going to be exactly one -1. I think. I guess not, right? Actually, it could be like 3 goes to 0 and that's a cycle and that's fine. Yeah. Each node has at most one outgoing edge. Okay. So here the nodes is 0 and 1, and 2 is the smallest index. The distance from 0 to 2 is 1, and the distance from 1 to 2 is 1. The maximum of those distances is 1. Okay, so the maximum between the node is minimized. So it's like the nearest one, I guess. Find closest node to 2 nodes. It can't be 3 because then it'd be like 2 distance from each. And it can't be like, actually can it be 1 or 0? I don't think you can actually go to 0 from 0, 1. Here, nodes are 0 and 2, so output should be 2, I want to say. The distance from node 0 to 2 is 2. The distance from node 2 to itself is 0. And then there's no other thing you can do. Yeah. It can be proven that we cannot get a node with a smaller maximum distance than 2. I mean, can you even use 1 at that point? Because you can't actually traverse to 1, right? Like from 2 you can go to 1. Distance from, I mean, it's a directed edge, not undirected. The maximum distance between those two is 2. We can move that we cannot get a node with a smaller maximum distance than 2. Let me do a test case here and say use the last one. Oh shoot. No, I don't want. Fuck. I did not want to lose the edge. What was the case? edges is this, node is 0 and 2. 0 and 1? This is 0 and 0 and 2. So if I do something like what if I did something like, I guess 0, 1 would still be 1, 0, 2 is going to still be 2. So in this configuration, it's not possible to make it impossible. What if I did starting with this? What if I said that the two nodes were... Is it ever impossible? I guess it's never impossible because it's all connected. No, I guess no, they could be separated, no? Like if I said one is going to nothing, so it's two separate graphs. So I think it should be there should be a case where it's impossible. Like let's say one goes to itself. Actually, this is 0 goes to itself. Or 0 is not connected to these two. And my two nodes are 0 and 1, so this should return negative 1. Yeah, so if the two things are not connected at all, then it's not possible. So I think I first need to determine whether or not it's possible that they're in the same kind of connected portion of the graph. If they are in the same connected portion of the graph, then eventually they should hit something. There should be some leaf node that they both share. So first determine if possible. If impossible, nodes are in separate unconnected graphs, basically. So how do we determine if the nodes are separated? I think what you could do is you can start with any arbitrary node and then have a set for that. Have an array of sets where each index matches the set that you're dealing with. And then every time you add on to a node, it adds on to that set. Yeah. Okay, so let's go ahead and say every, let's say, groups is going to be an array of sets. But I want this to be initially not there, so maybe -1 times the number of nodes. And then for every node in the range of n, if the groups for this node is equal to -1, then I'm going to go ahead and actually, if the groups for this node is already known, then I want to skip it. Otherwise, I'm going to go ahead and create a set for this node where it's added to that set. So something like this, and then I need to basically do a search through. Do I need to make a graph of this thing. Have I made a graph yet? I don't need to make a graph because edges is kind of that graph already. I don't think there's another way of connecting besides edges. Okay, so for every, and it's only one-to-one actually. Like there's only one neighbor for every node that I'm dealing with. So it goes like, if I start with 0, then it goes to 2, goes to 3. So those are just added to this set. So while the edges of this node is not equal to -1, then I'm going to say this node is now equal to its directed node that it's connected to. And I'm saying say group.add this node, and I'll also say groups connected to this node is equal to the current group. I also need to say group. I'm going to do it for the very first one as well. Groups for this node is equal to this current group. Seems like maybe there's a better way of writing it where this line doesn't appear twice. So I start by adding it to the group. Later, we have to start this while loop. Well, node doesn't equal -1. Yeah, I think I can do that. So I can say while the node doesn't equal -1, add this node, and then groups. At that point, I don't even need to do this. I can set it to be empty initially, and then groups for this node is equal to this current set, and then node is equal to edges of this node, so it goes on to the next neighbor. Okay, yeah, so you start with empty set, and then you add the node to that set, and then you say that the group that this set is associated to, the group that this node is associated to is this particular group. Go on to the next node, keep on doing that until you reach -1. What if you never reach -1? You have to reach -1, right? No, actually, there's an issue where this could be a cycle. Like it could go 0, 2, 3, 0, 2, 3. While node not equal to -1 and node not in group. So eventually, if you hit something where you actually cycle into the same thing, yeah, I think that's fine. Yeah, definitely that's a cycle. So 0 could go to 2, could go to 3, could go 0 to 2. And then 1, yeah, this doesn't quite work. Because let's say I do 0 and 0, 2, 3 is one group, and then I do 1, and then 1 eventually hits 2, then technically 1 is part of this whole group as well. So I think there needs to be another condition here. So create empty group while and node not group, add the node. So how do I say that 2 is, if I have a node that starts and goes to a node that actually is already grouped, then this new group needs to combine with the previous group. So you add the node, that's fine. You go to the next node. I think I say here that the next node is not in a group. And groups of this node equals negative. So it's either going to end, okay, it's going to end in something that's already grouped. So something that's already grouped. This node equal to negative 1. At this point, the node could be negative 1. If node equals negative 1, keep on going. So if you go to 2, 2 is already grouped, then everything inside the groups needs to merge. If either end in the same group and different group. If group not equal to groups of the node that you ended with, then you combine groups. So for every element, for every node in the current group, I'm going to say the groups of the current node dot add this node and groups this node. Oh, this is double usage node. For every k in group, combine groups if reach, if terminating in another group. Every k in the original group, that original group is going to be added to the other group, and then the node itself is going to be assigned to the other group. Yeah, so like 0 creates a group, and it's going to make a group that includes 2 and 3. And then when 1 does its turn, it's going to create a new group. And then when it hits 2, it should say that groups of that node is not negative 1, it's something else. So it breaks. The node itself is not negative 1. And then the node itself currently is 2. And then because the newly created group is not the same as the group for 2, then everything inside groups 1 group is going to be added to groups 2. And then, yeah, okay, I think this is fine. Let me go ahead and just print out what groups has after this. Return 0. Okay, yeah, this is right, because -1 is pointing to is creating 0 as its own group, and then 1, 2, 3 is connected. And here they're all the same groups. And if I were to make this thing like what it was before, 0 goes to 2, 1 goes to 2, 2 goes to 3. This should make it so that they're all going to the same group at that point. Yeah, okay, perfect, perfect. I wonder if there's a better way of combining groups, combining sets, rather than iterating through each. I mean, I have to iterate through each in any case because I need to reassign the group index, the group that is referencing the groups array. So this is groups array. References the group associated with each node, includes that node in connected graph. Okay. It's possible that something end up being just itself. Okay, so at this point I can say if the two nodes are in different groups, then it's not possible. So if node 1, groups of node 1 not equal to groups of node 2, and return -1. And if it is possible, then if it is possible, then I could probably do what? I could probably just go down the chain of adjacent things to each node until it reaches something that is similar, something that's common. The smallest index. Return the node with the smallest index. How could there possibly be multiple answers? 0 goes to 2, 1 goes to maybe 3, 3 goes to 2. There should always be unique answers, no? In what instance would you see multiple answers? So, I don't know. Interesting. Okay, anyways, let's go ahead and try say while true. Let's say scene is equal to scene is a set, and start with node 1 and node 2 scene. Actually, can I just create a set using curly braces? Python set. Ah. Yeah, it's just curly braces. So let's say scene is a set with node 1 and node 2. And while true, I still need to know. Yeah, I think this is fine. Each iteration of this loop is going to move forward each node by 1 to its adjacent. So can say here what if moving one where he makes it same, and node 1, node 2 be the same. Node 1, node 2 are between 0 and n. They could be the same. So actually I'll just say here, if node 1 equals node 2, return the node which is that same thing. Right, otherwise they're different. I'm gonna start with set that is, so let's say I start with like 0 and 1. So I'm gonna now add both their, I'll add both their neighbors to it. So like scene, actually let's say next one's edges of node 1 and next two's edges of node 2, and I think it's likely that if one of them goes to -1, then that means that that thing has, so let's say like you're dealing with 0 and 3, because 3 goes to -1, that means that 3 has to be like the future of 0. So I think this is true. Like if next one is equal to -1, then I return node 2. Now I return node 1. And if next 2 is equal to -1, then return node 2. Otherwise, they're going to converge at some point. Is that correct? Maybe that's not correct, actually. Like maybe there was an earlier one that was the future of node 1. So it could be 0 to 2 to 3, and then it could be like something all the way up to 1 to 2. Yeah, actually this is right. I do need to say that if node 1 not equal to -1, then I do the next of that. And if node 2 not equal, interesting. I think there might be a hack for me to not have this if statement, but I'll figure that out later. So if node 1 doesn't equal -1, then go to the next. Node 2, go to the next. And if I say if next one is in scene, then return next one. Next 2 is in scene, and return next 2. Otherwise, scene is going to add next 1. Scene will add next 2. And return, and node 1, node 2 becomes what next 1, next 2 is. I still don't know why you would ever need to worry about multiple answers. I guess I'm going to find out when this thing doesn't work. But This is just a while true loop, right? So this is always going to find something. Yeah, so this is going to be, say return -1, this can maybe fail at some point, or maybe go infinite. Timeout. Interesting, interesting. The output here was -1, but the expected value was 2. So somehow I detected that they were not in the same groups. They should have been in the same groups. 0 and 2. Are they in different? Could be that the reference themselves are different. No, it's the same group. So somehow, so print out the groups. It didn't return -1 because of that. Did it actually go past the while true loop? So it didn't print here, so it didn't return there. Oh, it returned node 1 here when node 1 is -1? Really? Same node. Okay, so it didn't do that either. So why does it return? So scene was -1, I see. Okay, so let's go ahead and see what the iteration of this thing is gonna show for the scene. So initially it sees a 0, 1, 2. Oh, I see. It sees 2 at the same time, so it never actually, yeah, it sees 2 at the same time. So I think what I do here is, if next one is seen, then return next one, otherwise add it immediately. I think this should fix that issue. Okay, yeah. Okay, so let's go ahead and comment out some of the prints and see if it works on the bigger stuff. I'm assuming there's going to be a lot of crashes here. Hopefully it doesn't go infinite or timeout. So then timeout please. Let me go ahead and see what the groups are. Okay, so everything's connected, it looks like. And the output should be 4, but the expected output should be 1. But my output was 4. So the nodes were 5 and 6, 0, 1, 2, 3, 4, 5. So 5 and 6 led to 9 and 8. Let's go ahead and print out what is seen at the end of each run. So it should be 5, 6, and seen will be 8, 9. Here, 1, 2, 3, 4, 5. No, sorry, seen will be 8, 4 in the first iteration. 5, 6, 8, 4. And then next one, 8 would add in 1, and 4 would add in 0, 1, 2, 3, 4. 4 would add in 9. 1, 9 added. Next iteration, interesting. 1 would add in 4, and 9 would add in 1. 1 would add in 4, 9 would add in 1. And I should have done 1 as the answer there. Okay. So if next one, interesting. If next one in scene, turn next one. One in scene, turn next one. Otherwise add. Let me do this in order of whichever is smaller. So I think maybe I say if, I'll say smaller and bigger is equal to the min of two numbers say smaller is equal to the min of next one, and next two bigger is equal to next one plus next two minus the smaller one. That's just a hack to not have another if statement there. A plus B, yeah. And then I can do if smaller is in scene, return the smaller one. Otherwise scene dot add the smaller one. And then if bigger one is in scene, return the bigger one. Otherwise scene dot add the bigger. And then otherwise I'll say node 1, node 2. It doesn't matter. Next 1, next 2. I think I can probably comment this out. I could make that bigger and smaller as well. Doesn't matter. So it works now for this case, but it stopped working for this case. So this thing is now outputting -1 correctly. Zero goes to 1, goes to 2, goes to nothing. So you're starting with 0. Next one, if they're -1, then next one is that. This doesn't work if it's dealing with -1, right? If one of them's -1. If one of them's -1, then I need to not do this. If node 1 is -1, if it's not -1, then move on. If it is -1, then keep -1. Smaller is always going to be -1. really don't want to add -1 to the set of scene, do I? Actually, it never actually sets equal to it. No, it does. The next one becomes -1. Node 1 not equal to -1, then if node 1 not equal to -1, so in that case, what is next one for? So you have a node, let's say the node is 2. Yeah, okay, I'm confusing myself. What is scene in this case? Start with 0, 2, 0. Oh, I see. Start with 0 and 2. 0 goes to 1, so that's added. 2 goes to -1, so that's added. Fuck. So if the smaller and bigger one, if smaller is in scene and smaller not equal to -1, then return the smaller. If bigger is in scene, big one should be found. Should be always fine in that case. Okay. Kinda hacky. Very hacky. Answery. 57. Okay. Let's go ahead and print everything out again. Okay, so the expected answer here was 7 at 1. So it looks like they're all, well, the nodes 1 and 6 are connected, so 1, 6, 1 adds 7, 6 adds 16. Okay, and then 7 adds 2, 16 adds 14. Okay. 7 adds 2 and 16 adds 14. And then the next one, 2 adds 9. No, I'm reading this wrong. So 1 adds 7, 6 adds 17. 6 adds, I start with 1 and 6. 1 adds 7, 6 adds 16. So that's how I got 7 and 16 there. And then 7 adds 2 and 16 adds 14. And then 2 should add 15 and 14 should add 9. Okay. 2 adds 15 and 14 adds 9. And then the next pass, 15 should add 1 and 9 should add 9 adds 7. 15 1, 9's at 7. Is that not 1 as the correct answer? If there are multiple, return the node with the smallest index. Okay, I need to draw this out here. So start with 1 and 6. And then 1 goes to 7. And 6 goes to 16. And then the next one, 7 goes to 2. And 16 goes to 14. Next one, 2 goes to 2 goes to 7, no, 0, 2 goes to 15, and 14 goes to 9, 14, 15, 16, 17. Yeah, it's 9. The next one, 15 goes to 1. 15 goes to 1. And 9 goes to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 goes to 7. Interesting. How does this work out? What? 9 goes to 7. So the answer should have been 7. I see. Huh. Interesting. Then 7 goes to 1. But 1 was already seen. Huh. What does this mean? This totally is not what I expected for how this thing plays out. 1 goes to 7. Well, 1 doesn't even work, right? Because 1 goes to 7. So you start with 6. 6 eventually hits 7, which is after 1. But at the same time as 6 hitting the 7, 1 hits 1 does a cycle where it goes back to itself, and yeah, 1 does a cycle where it goes back to itself, so that it detects itself as being earlier. If it ever detects itself, it shouldn't necessarily stop. So if a node goes into a cycle, if a node ever goes into a cycle, then it's going to answer, give the node itself as the answer, even if that is not the correct answer. Huh. How do I not do that? So 1 goes to 7, goes to 2, goes to 15, goes to... So 1 goes to 7. Like, what it really boils down to is if it does a cycle, then you really need to look at the other chain. Look at the other chain and see where the other chain connects to the cycle, because the other chain connecting to the cycle is where it actually should stop. Huh. So maybe I need to have 2 separate groups. One group going from node 1 and one group going from node 2. If the latest that one group has is in the other group, then that should be the endpoint. But if the latest that the group has doesn't see it in the other group, then it's not an endpoint. Even if you detect it's in the same. Okay, so I think I need to have 2 same groups. So let's say path 1 is the set starting with node 1. Path 2 is the set starting with node 2. And while true, we go down each path. So let's say here that this is still fine. If node 1 is not negative 1, then go down to the next one. And same thing for that one. And I want to say here if I think small and bigger is fine still. If smaller isn't seen, actually, so this one should be in path 2. No. So it's a check to see if one matches the other. So if next one is in path 2 or next 2 is in path 1, then return. This logic is not correct. I just can't return the smaller one. Let me return the smaller one if it's actually both matching. So next one is in path 2. Actually, can I do that? Can I say if next one is in path 2, then return next one? And if next 2 is in path 1, then return next 2. Otherwise, go down separate paths. Like, this is going to go with the simultaneous issue. I think maybe next one is in path. Maybe I can say at this point path 2 dot path 1 dot add next one, path 2 dot add next 2. Maybe that's fine. And then I still need to say that node 1 and node 2 becomes next one. This is still gonna give a previous error. This is not gonna be good. Yeah, does this, well, now it does this one right, now it stops doing this one right. Is this a simultaneous issue? Yeah, I think this is a simultaneous issue, like 5, 6 becomes 9, 8, 9, 8 adds, no, 5, 6, 0, 1, 2, 3, 4, 5, 9, 6 becomes 8, 4, 2, 2, 2, so 5 becomes 8, 6 becomes 4, 8 becomes 1, 4 becomes 0, 1, 2, 3, 4, 9. And then 1 becomes 4, and 4 becomes 0, 1, 2, 3, 4. I think that's the issue. So 5, 0, 1, 2, 3, 4, 5 becomes 8. And then, actually, let me go ahead and just what's going on here. For every edges, print out the index edges, print, say index, and an arrow, and then edges at this index. So 'right. For every index in the range of n, okay, so start with 5 and 6. 5 goes to 8, 6 goes to 4, 8 goes to 1, 4 goes to 9, 1 goes to 4, 9 goes to 1. Okay. At that point you detect that both 1 and 4, can I visualize this? 5, 8, 1, 5, 8, 1. So it's like 6 goes to 4, goes to 9, 9 goes downwards to 1. So 1 should be the answer. One goes to 4. 1 goes to 4. 5, 8, 1, 4. So there's a little cycle right there. And 6, 4, 6, 4, 9, 1, 4. So in theory you could go, you can use 1, and it's 3 apart, or you could use 4, and it's also 3 apart. I see, I see. So I think here I can say if next one is not 2, if next one path 2 and next 2 is path 1, return the smaller of the two. Otherwise do it separately. It's kind of awkward. Smaller is in the min of the two. Kind of awkward if statement. If statements. I think I can do this printout now. And this printout for now. Oof. Alright. Not my greatest. This is really bad, actually. Like, there's something that actually is like 30 milliseconds. Holy shit. Huh. Given two nodes. Given two nodes. How to do this quickly? So maybe I can. Wonder. Can I just do the second portion and maybe detect that it's not possible while doing the second portion? So if I do the second portion and detect that it never hits the first portion. Yeah, I think this is slowing it down considerably, finding which groups things are in. And maybe that's just not necessary. Okay, let's see if I can't do it without the group steal. So I'll say path 1 is the set with node 1, and path 2 is the set with node 2. And I can say while true, next one oof. I almost want to do this hack idea that I have, but let's try it without the hack idea I have in my mind. If node 1 not equal to -1, then node 1, then next 1 is equal to edges of node 1. If node 2 not equal to -1, next 2 equals edges of node 2. And path 1 dot add next 1, path 2 dot add next 2. I want to say that if I detect a cycle, actually I can if I detect a cycle, then I should stop. So, and if I detect a cycle or a termination in a -1, I should stop. Let's say done 1, done 2 is false. So and I can go here, if done1 and done2, then return -1. Okay. This should eventually return something. Otherwise, so how do I know that something's done? So if it's equal to -1, then done1 equals true, done2 equals 2, true. So it's done if it goes and terminates, or it's done if it finds that it's cycling. So I can say here if maybe not done1, if not done1, ooh. Okay, so I can say next one is future build 1. So many things I want to do simultaneously, like adding stuff to the sets, or adding stuff to the past, checking for doneness, checking for -1. Alright, so if I have something that's not -1, I see what the future of it is. If the future is already in the set, then it's done. If next one in path1, then done1 is true, else path1.add next one. I'm going to do the same thing for node 2. What if it equals -1? If it equals -1, then it should also be set to done. You know what? I think I can do something like this. I can say edges dot add edges dot add -1, append -1. So that means that if you're dealing with something where the node is itself -1, then it goes to -1. But then you can find that the path ends in -1. In which case you say UN. In which case you maybe return -1. Actually, maybe that works out. Node 1, maybe not this. So regardless, next one is equal to edges at that node. And then if next one is in path 1, then done1 is true. Regardless, I think you can always add, but you probably should just else this. And then if next 2 is in path 2, then done2 is true, else path 2.add next 2. And then you do that with your if statement stuff. Next one and next 2. Okay. You actually need done1 and done2 at that point, because at some point you have -1 both sets, and then you just return -1. Yeah, I wonder. Okay, I'll test this out without checking that possibility. Path to next to next to equals edges of node 2. Oh boy. So 0 goes to 0 goes to I see. Because -1 is found the same time that actually see 0 goes to 1, 2 goes to -1, and then 1 goes to 2 at the same time as -1 goes to -1. Goes to 2. Oh, because next one is at that point -1. So it's returning the minimum of print. This is turning min of next one, next 2, and I think this is that point 2 and -1. Yeah. Returning this thing. This next one. So first path is 0, 1, the second path is 2, -1. And then the next iteration, first path still has 0, 1. Say, oh, did I never set node 1 to become node, shucks. I forgot the last statement. Node 1, node 2 equals next one, next 2. Work. There. The correct configuration the answer should be 0. I got 5. The nodes are the same. Wasn't this one of the edge cases that I already did? Yeah, same node. That edge case should have been added at the very top. Okay. So is there another case that I need to resolve? Oh baby, sweet. Okay, so what What did I do here? There has to be some better logic here. This is just so messy, this logic. But so I added -1 to the end so that it doesn't go out of bounds, it just looks at itself. When it references this next one, because if it references -1, that goes to the ending that I attached. So I look at different paths. If next one, so I don't think I used done at all. I don't think I used done at all. Or it's possible that I don't need to use done. I just say path1 add next one, path2 add next two. And then let's see if this still works. Yeah. And then if the next one is in path 2 and next 2 is in path 1, so they kind of simultaneously hit each other, then you have to return the minimum. But if it's not simultaneously hitting, then you have to just look at one or the other. Oof. This logic right here seems like there should be another way to write this that's slightly better. I think maybe you can say if next one in path 2 or next 2 in path 1. Then you change out and for an or statement. I don't think that helps at all. I guess next 2 and next 1 is not necessary. You can just say node 1 is becoming the future of node 1, node 2 becomes the future of node 2. Add node 1, add node 2. In that case, now if node 1 is in path 2 and node 2 is in path 1, then return the minimum of these two nodes. Otherwise, if node 1 is in path 2, return node 1. If node 2 is in path 1, return node 2. And with that statement, go infinite. Oh boy. Yeah, I did go infinite. I did need to check done. Because they're two different. They could be in two separate paths. So I did need to do that done thing. I say if node 1 is the edges of node 1. If node 1 is in path 1, then and node 2 is in path 2, then return -1. See if that works for that test case. Slightly improved. Move done there. Alright, so I'm going to do a little bit of commenting here. So same node. Same, this is going to be trivial case. Same node, best node, shortest node is itself. And then here to not worry about indexing using -1, add an extra kind of dummy node to end, since -1 index will refer to last node in Python list. Track the paths of both nodes, and each loop iterate to next node in each path, and then if paths are cycles that never hit or intersect, then return -1. So if you go to a node that's is oriented the same path, or a node that's node 1 that's oriented path 1, or node 2 that goes in path 2, then that's a cycle both. Otherwise, add extend paths sets, and if the paths intersect, then return smaller intersection, node/index. So if node 1 hits path 2 or node 2 hits path 1, then return the smaller of the two. Yeah. Yep, that seems pretty good. So summary, track paths using sets, and here we want to use sets rather than lists, since a node could hit any previous node in other path. And extend path one step at a time. Node becomes equals to edges of that node. And one, detect when impossible. Cycles where node or both node hit a previous node in its path, or both node 1 and node 2, or 2 when a node intersects with any node in other path. Time complexity, this is going to be O of n, where n is the number of nodes. I guess O of n plus m. N is number of nodes in path. No, it's O of n, where n is number of nodes. It's possible to need to go through every node to eventually figure out that they're connected at the very end. And then space complexity, this is O of n to maintain sets where sets can contain at most n nodes. Well, I made this a lot harder than it needed to be, but I eventually reduced it down to experimental, I think.